Canary is an amazing project that has captivated my mind for the next 2 days, and it has caused me lots of stress, lots of monster these 2 days. It's a project inspired by miners that breathe toxic fumes and use the bird canary to not breathe toxic fumes because those birds die faster than the miners die. But you don't need to kill animals anymore because we're in the future with technology. And with this technology, we'll be able to kill digital canaries and prevent animal abuse and also prevent toxic fume inhalations because this has tons of toxic fumes when it prints. It's very bad for you. My name is William Huang, the nonchalant leader and cool, charismatic, awesome.
I've been holding pee for 2 hours because get back to work.
I'm the love me.
Oh, you're ruining my video. You're gonna make us lose hackathon. Oh, what the hell?
This is our 3D modeler. His name is Jordan.
Monsters down.
His name is Jordan Lee, and he's the GOAT at Fusion. He has 5 years of experience, and he's used half of my filament. Cheers to what keeps me awake at night. I'm about to enter the programmer's den.
He's gonna touch me.
Type them up for the Canary. Here we have a BME 680, which we didn't want these are, so stuff to components ESP32, and LS screen 4 push buttons. Press button 2. So this button calibrates it, reads the air temperature around the room, and then takes a while, calibration complete, and then goes back to the menu screen, which you can press the first button 2. Have a little pal. If I blow into this, he'll get worse. And he'll get even worse. And he'll just die. That's funny. Okay, here's the actual code map for the Canary version. Alright, so these are bitmaps, using bitmaps to display the actual Canary on OLED screen. And what's interesting, if you look outside, it can roughly show you what it'll look like. These are constants, variables, and we have this Alfruit SC36, which just initializes the LED screen, and these functions are for menus. So stuff like the Canary, the calibrate menu, if you press button, it calibrates it through this long process. It uses BME to sense air pressure, and then it averages out. The Canary, it reads the current gas resistance, air pressure, gas resistance, and aperture statements to change how long it beeps and how much and which word it draws, depending on the air quality. And then there's the OLED display stuff, to actually display text. Here's info page, just a big info page that prints all the lines. Well, it's set up to set up everything. So set up serial, set up the pin mode, set up BME, see if the BME is even connected, see if serial is even the same. Clear display and like so it doesn't go all over the place, so it doesn't go down. And loop to see if the input pins are being powered. If they are, then go to the menu. If they're not, then don't. And it checks if it's calibrated through a variable. So if it's not calibrated, then it will not allow you to go to the actual Canary part, the actual sense part. That's it. See you.
Hi guys, this is team leader next to our programmer, James Zhang. I'm William Huang. Today we're going to do a quick code demo. We're using Platform.io as our main source of firmware thing. Here's the code that we wrote. So first we have the libraries, the imports. We need the screen. And we need the, okay, fine. Here are the images that our programmer James wrote.
Got from the internet.
Yeah, he got it from the internet. He drew them by hand. Here are the pin assignments. We have 3 buttons and 1 buzzer. We use the BMP, initializing the object. We use the buzzer, we use the OLED. We should probably get rid of that extra comment there because it is there. And those are variables, temporary variables that get changed. We have a structure set up for temperature ranges to make sure like what temperatures are good ranges. So we have like a minimum and a maximum. And anything that's too cold, we'll give the dying one. Anything that's too cool, we'll give not healthy. Anything, yeah, you get the gist. Setup. We basically just initialize a bunch of stuff. We initialize the pin mode, we initialize the serial, we initialize I2C and the buzzer. And the OLED and the BMP280. This is the code for the final project, which is why we have the BMP280, unlike the prototype, which has the BMP680, which has more features. Also, this just displays the main menu for now. At the setup, we have display menu. It's a function. This function, when ran, will display the menu of the currently selected items. We have a integer that tells us the current selected item within the menus. It ranges from 0 to 1 because there are 2 items. We have select menu items, which is ran when we select a menu item, and basically it checks if it's Canary or it checks if it's info, and if it's info, it displays Canary's info stuff, and if it's Canary, then it turns something called Canary active true, which will then allow the thing to start reading the temperature data and stuff. Yeah. This is a loop. Basically, all the loop manages is handling the buttons that are being pressed, and when it detects a button being pressed, it will run selection of menu, and it will also run Canary active, which is basically real-time updating of the Canary. That is literally all.
Yes, sir.
The current version uses the BMP28, which can sense temperature and pressure. However, there are modules attached to this device, like the BME680, which will be able to sense toxic fumes. The prototype uses the BMP680. The product only supports the BMP280. This is the uploading our firmware to this thing. Custom drilled thing that I made myself because I forgot to support this. Now we will be uploading some firmware. This is our code, our very nicely made code, and this is the bitmaps that our programmer made for us to draw on these canaries. The code is just mainly detecting button presses. One of the hardest parts of the code is probably working with the BMP280 because the documentation on it is extremely bad, and you always make it really hard work. But here is our menu. By pressing this, you can go up, and pressing this, you can go down. And by pressing the middle button, you should be able to select. This is info, so it tells you a bit about our product, and this tells you a bit about the environment. So the image here will correspond to the canary. So if it gets to a temperature that is not good for you, like this, then the canary dies, and it's not good. And it goes back to life when you pull it down. That's my tech code, guys. Have fun. You guys, it's very important to your health because if you went into a room that was too hot for you, you would get heat stroke and die. Also, if you breathe in too much toxic fumes, you would also die. We call it toxic canary because miners use canaries, the canary bird, as something to indicate toxic fumes in the mines. Also, because it's important for toxic gases because half the time you're going to immediately detect toxic gases in the air. And by the time you're toxic gases, so by using this technology, you can track out the poison gases before they transfer your lungs and you possibly die. Yeah. Also, this is a common problem. You may think that toxic gases are a common problem, but with global warming and carbon emissions, there's tons of bad stuff. Also, in most areas of forest fire, so you probably seen stuff about bad gases in the air. And also, people don't do printers, the PLA plastic fumes are really bad for you. So if you have it next to your living room like me, don't do that. You should probably go to the basement.